Solutions to assignment questions. This question you have to complete ray diagrams. First, you draw light rays passing through the center of the lens. Then, you may draw a light ray parallel to the principal axis. Note that it is concave lens for the bottom right corner. Then you may try to locate the image. You can find an image for these two cases. But for the other two cases on the right hand side, you have to draw virtual rays first of all. Then you may locate the image. And don't forget to draw a dotted arrow for virtual images. And the nature of images, they are listed here. For the next question, you have to draw a ray diagram for different cases, such as convex lens, when the focal length is 5 cm, object distance 15 cm, and object height 5 cm. First, you have to mark the foci on the two sides. Then, mark the object, and make sure you draw it with the correct scale. Next, you draw the construction rules. You may draw any two of them. That one passing through the center of the lens, and also one parallel to the principal axis. Of course, you may also draw another one in order to locate the image. You may draw just any two of those three construction rules in order to locate the image. And the image in this case is real and inverted and diminished. Next, it is a concave lens. Similarly, you have to mark the foci on the two sides, and then mark the object accurately. Now in this case, again you have construction rules, and you may choose any two of them. The one passing through the center of the lens, and the other parallel to the principal axis. And this light ray diverge away in the direction of the focus. And don't forget to draw the dotted line passing through the focus to show its direction. And then the intersection point is the tip of the image. And so the whole image looks like this. You may also draw the third construction rules in this case. Not that easy, but you may do so. You may also draw these two or that two in order to locate the image. These ray diagrams are all correct. Finally, the nature of the image is erect, and all erect image must be virtual. And this image is diminished. That means smaller than the object. Next, what about for this question? First, you have to locate the image of the tip of the object. In this way, it will be here. So the image is inverted, and all inverted image must be real. And lastly, it is also diminished. Then for the last light ray, for the light ray in this diagram that comes from the middle of the object, then it should pass through the middle of the image. And for your question, there is a light ray comes from the tail of the object. And so this light ray will pass through the tail of the image. Here comes a concave lens. Similarly, we have to find the image of the object first, and we talked about the tip of the object. So there should be two light rays, one passing through the center of the lens, always correct, and the other parallel to the principal axis will be diverged away in the direction passing through the focus. So this point will be the image of the tip of the object. So the whole image look like this. And if there is a light ray that comes from the tail of the object, then this light ray will be diverged away, and then it will also pass through the tail of the image. And for your question, there should be the light ray that comes from the middle of the object. So this one will pass to the lens and then diverge away in the direction from the middle of the image. What about this question? The object looks like this, which is not vertical, so you have to find the image of the tip. In this way, this is the image of the tip. And then also find the image of the tail of the object by drawing two light rays again. So the whole image will look like this, which is inverted, and so it is also real and diminished. As you can see, it is smaller than the object. What about the last three questions? You have to draw ray diagrams, and you must draw it very accurately. Using a scale of 1 to 5, you may use the following values to draw the ray diagram accurately. And then the image height is found to be 1.6 cm, and the image distance 7.2 cm. So the answer for part B, 36 cm, and the image height 8 cm. So the magnification x cm divided by 10, which is the original height of the object. So 0.8 is the magnification. This is a similar question, but now the object is a bit closer to the lens. And when you complete the diagram accurately, then you should find that the image has a size of 2.5 cm and image distance 9 cm. So the actual image distance should be 45 cm, and the actual image height should be 12.5 cm, and magnification equals 1.25. So what's the similarities between the last two questions? If you look at the two ray diagrams more carefully, then you can see the object distance in question 65 equals the image distance in question 66, and the image distance in question 65 equals the object's distance in question 66. In other words, in these two questions, the object and image, they interchange their positions. And that's why the product of the two magnifications, 0.8 and 1.25, will be equal to 1.